Hi everyone, welcome to Foundations of Machine Learning. I'm really excited to have you here. Whether you have just started learning Python or you're curious about how AI systems actually learn, you're in the right place. Over the next 6 weeks, we are going to take this journey together, step by step, from very basics of machine learning to build your own intelligent models. So don't worry if some things sounds new or even little intimidating. My job is to make sure every concept feels approachable and practical. You'll get to see how data turns into predictions and how models actually learn. And by the end of this course, you will be confident enough to run small, real world ML projects on your own. This week, we'll start from the foundation. What exactly is machine learning? How is it different from traditional programming? What are the main types of ML? How does it connect to artificial intelligence and deep learning? And what kind of real world problems can it solve? You will set up your Python tools and run your first simple ML program. That's gonna be our mini celebration at the end of this week. Let's start with a simple question. What if you could teach your computer to learn on its own? Imagine this. You have hundreds of examples of email. Some are spam, some are not. Instead of writing 50 if else rule, like if the email has word lottery, mark as spam. You show the computer examples of what spam looks like. Then the computers learn the patterns between the features, meaning the word, sender, and structure, and labels, which is spam or not. That's machine learning. Letting data teach the computer what to do. This shift from manually writing rules to letting computers learn from examples is what makes ML revolutionary. Now let us see what is the difference between traditional programming and machine learning. Let's compare them both side by side. In traditional programming, we provide data and rules which gives us output. For example, we tell the computer if the temperature is below 18 degrees Celsius, turn on the heater. But in machine learning, we do it differently. We give data and output, which is rule, meaning we make the model. So we show the computer's example like temperatures and whether the heater should be on or off, and it learns the relationship itself. It's almost like teaching child by example, not by giving them the rule book, but by showing the patterns until they figure it out. Take a moment to think about this. Where do you find you have already experienced machine learning in your daily life? Pause this video for a few seconds and list 3 examples in your notebook. Anything that feels like the system learns what I like. Maybe YouTube recommendation, face unlock on your phone, or even Gmail spam filter. Now let's define machine learning. So how do experts define it? One of the earliest definition came from Arthur Samuel in 1959. He said, machine learning is the field of study that gives computer the ability to learn without being explicitly programmed. Simple, right? It's about making computers learn from data, automatically improving their performance with more experience. Let's think about this visually. Imagine you have a scatter plot, dots showing our study on one axis and exam scores on other. You can almost almost see a pattern as the study hours increase, score go up. Machine learning finds the line that best fits those points. Next time, if a student studies for 6 hours, the model predicts the likely score. That's your first mental picture of what learning from data really means. So let's see what that looks like in a code. Don't worry, I'll explain each line as if we are typing it together. From sklearn.linear underscore model, import linear regression. Import numpy as np, where x is the hours studied and y is the exam scores. So for x is equal to np.array, we'll declare an array which is 1, 2, 3, 4, and 5, and y, which is supposedly the exam score. Also, we create an array called np.array 40, 50, 60, 70, and 80. We'll declare model is equal to linear regression and model.fit is equal to x comma y, and we'll print the score. What's happening here? We import a simple ML model called linear regression from scikit-learn. We provide x and y, which is input and output examples. The model looks at the pattern and learns the relationship. Then we ask, what if someone studies 6 hours? The computer predicts the score around 90. See how natural that feels? We didn't give it a formula, it figured it out by learning from data. So pause here and open Google Colab or Jupyter Notebook and type this exact code and run it. If you see a predicted score, congratulations. You have just built your first ML model. Feel free to play with it. Try different numbers or scores and see how the predictions change. So, what does learning mean for a machine? It doesn't think like us. It looks for a mathematical relationship in data. For example, in our case, it finds that for every 1 extra hour of study, the score increases by about 10 points. The model adds something called parameters like the slope and intercept of a line until it best fits the training data. The more data it sees, the more accurate its understanding becomes. That's why in ML we often say data is the new oil. Imagine a looping animation showing data, model training, prediction, feedback, and improvement. This cycle repeats. The more the example, the smarter the model gets. So, to summarize what we learned today, machine learning is about letting computers learn patterns from data. It replaces handwritten rules with experience from examples. You just built your first tiny ML model, linear regression, that predicts exam score. And we have begun to understand that learning means improving with data. That's a huge step for day one. Seriously, well done. Before you wrap up for today, I want you to think about this question. If you could train a machine learning model on any problem in your daily life, what could it be? Maybe predicting how long it will take to finish your coffee before it gets cold? Or guessing your monthly budgets from spending habits? Write your answer down. This little imagination exercise help you to connect what we are learning to real life.